I believe we are here now, but I won't believe it until I see YouTube update. Okay, I'm going to trust the process. I'm going to trust the technology. I shouldn't, but I'm going to. Oh, there we are. So, Jess and Brian from Fission, welcome. Thank you. As I was saying right before I pressed the button, it's really nice that I get to be selfish about these things because I'm going to learn something today that I've been wanting to learn from you. But at the same time, I think others will also be excited, even if they don't know what it is yet. So, Jess, I think you had an intro to the topic that you wanted to go through. So I will just let you take it from here and then I'll interrupt.
Yeah. No, thanks for having us, Chad. And yeah, always a pleasure to do this kind of stuff. And Professor Brian for joining along for the ride. It'll be a lot of fun. Cool. So today, Brian and I were talking about what would be most interesting to show off. And I think one of the, what we're going to dive in today is a thing called Web Native that Fission has been building, and specifically a thing called Web Native App Template. And we're actually going to build an app with it today. we're not just going to sit around and talk. We're actually going to get in, open a terminal and clone and go. And we'll see how far we get with actually building, because we'll be learning as we're going. But I thought maybe a quick preface to what the heck is Web Native and Web Native App Template before we actually start writing code might be helpful. So Web Native, and I'll actually go ahead and share my screen because it will be helpful to see some of this stuff.
While you're doing that, is it actually called Web Native or Web Native File System?
So Brian, you want to take that
one? Yeah. It is called Web Native, the Web Native SDK. And one of the things that the Web Native SDK provides is WinFS, which is the Web Native file system. So the Web Native SDK is a broader sort of umbrella that has a few other pieces included in it.
Cool. You got it. No, that's a great question. And it is Web Native. By the way, the N is lowercase. I know that really bothers some people about casing, and the W is uppercase, just in case you're that kind of persnickety person like me. So the Web Native SDK, what this is a little JavaScript library that you can drop in to build a fully distributed web application. And what we mean by that is it includes a bunch of things, only a few of which we'll actually be able to get to today, probably. But the Web Native SDK includes user accounts, so it can basically rather than having usernames and passwords, we use public private key cryptography and the Web Crypto API to create accounts, which we'll look at some of that today. We also include authorization using UCAN. So instead of having a centralized authentication server that says, or authorization server that says you can or cannot do this or that, we have a decentralized system called UCANs. We'll also look at those today. It also includes encrypted file storage, which is what Chad was just asking about, the Web Native file system. That's built on top of IPFS, if people are familiar with that, and provides public and private files on top of IPFS. And then it includes this cool feature that we'll probably walk through today as well, of key management, where you can actually transfer a key between multiple devices in order to basically authenticate several different devices. And that's like a secure flow. So that's the Web Native SDK. But if you think about user accounts for a second, y'all are probably familiar with things like Auth0, or let's say Google's, login, sign in with Google. There's a whole user flow, front end that's included with that experience that Google provides or Auth0 provides, or you can customize your own if you're crazy like that. But the Web Native SDK doesn't have any HTML and CSS in it. It's just the JavaScript. And so it's pretty important to have that user flow. And so that's why we built the Web Native App Template. So, and that's what we'll be working with today. So if folks want to go dig around right now of what we're working on, feel free to go to Web Native Examples, Web Native App Template, and poke around here. The README shows a lot of stuff. But basically what the Web Native App Template is a batteries included, fully working application that wraps Web Native and provides all of the front end stuff. So you get a user, and we'll show all this in just a second. You get to log in with a user and create an account, all that kind of stuff. And it has handles error cases really nicely. And the goal was to make it really, really simple for a developer to get started using Web Native SDK. They can just come up here and say, use this template, create a new repository, and boom, they have a working application that they can now customize, as opposed to having to start from scratch, npm install Web Native, and then have to build all of the things themselves. So
yeah, especially the CSS. No one wants to do that, right?
yes. And no one especially wants to watch us do that on a live stream.
Me, that's who they don't want to see.
We can say thank you to Ryan and Andy on our team for making this app look really, really stellar. Yeah.
Thank you, Ryan and Andy.
And just there's one thing I wanted to bookmark and mention in terms of key management. You'd mentioned that it allows you to transfer keys. We actually never transfer keys. We actually authorize from one key pair to another. And I'm saying we'll bookmark that because I think that we're going to get into that a lot more deeply when we start looking at the awake flow to connect to browsers.
Now, that is a really good point, and it is a really critical distinction. Yeah, so what I've got, I already cloned a repo. So basically what I just did this morning, so we don't have to wait for on the stream, is I went up, used this template, create a new repository. One other thing I should flag real quick is that we are right at the end of a major refactor of the web native library, like web native, this web native. 0.35 is the version there. And we actually have an alpha version up on NPM, so you can install that alpha version if you'd like to play with it right away. But we have not updated web native app template to that. It's on 0.34. So I've already done the work of cloning a template, cloning the template and updating that template to 0.35. So if you want to look at a 0.35 version, you can go to Web Native Examples and Web Native Contacts example. And if you want to like follow along with what we're doing today, you should probably clone this repo or fork this repo instead of using the use template just today. If you're watching a recording of this, 0.35 has already landed. Just click use this template and clone and create a new repository, and you're good to go. Cool. All right. Well, I've already got this locally, so I'm going to switch over to my editor, Web Native Contacts example. Notice the same name there. Just for like some layout stuff, I keep my terminal on the right and my editor on the left for all the things. And I've already done an npm install, I believe. Yeah. So we're going to do an npm run dev, which I should mention, I guess, that this repository, this app template is built on SvelteKit, if you're familiar with that. So it's running Vite underneath the hood. And all right, if we start that up, we should be able to see the app in progress. Cool. So this is it. This is what you would get if you did clone template. It is a fully working app. It's got a bunch of boilerplatey stuff in here to guide you, the developer, through the template. Obviously, you wouldn't ship this to an end user, right? But it helps you to know what the heck you have. I was really inspired, Chad, by the Rails starting page from way back in the day. Like when you would do a Rails new and you start up your Rails server, you actually had a page that told you what to do and like directed you to docs and all of that kind of stuff. And that was a much more fuller version of this in the Web Native app template. But that was the inspiration here of like, give you something that like, as a developer, you know what you have and what you can do with it.
Yeah, it's hard to believe that used to be unusual because like everyone was inspired by that. And the whole idea of like developer friendliness and usability right out of the box for developers has advanced a lot since then too.
It is a really nice thing. So I'm going to walk through the actual login flow. Like I mentioned, this HTML and CSS is included to make it easy for you to get started. One thing I'll mention as I go through, you either might find this design really awesome, like Brian and I do, or you might hate it. And if you hate it, that's fine. It's actually really easy to customize the design. So you can actually drop in, it's all built on Tailwind. Tailwind makes it really easy to customize colors and shapes and rounded colors. And you can basically specify it in one file and it propagates throughout the entire application.
And you don't have to use this anyway, of course. It could be just how you learn how to set it up. And you could port
absolutely.
It you want.
Yep. This could be the toy app that you build before starting your thing from scratch with the Web Native SDK. All right, so I'm going to go, you can see here, I have an existing account or create a new account. We're going to start with create a new account. Maybe create a new account. Second time's the charm. There we go. And
it has to mess up somehow. So you've got your one error now. So we're done for the.
There we go. Yeah, the wrinkles are all out. The gremlins are done. All right. So here we did some nice stuff in terms of you can actually do username checking. So Jess Martin has signed up before. This is this sitting staging or production? I can't remember, Brian.
It should be on production, I think. Yeah.
Yeah. So I've already got a Jess Martin on production, but I don't have a Jess Martin 1. So I can click register now. Note the initializing file system. We'll come back to that. Welcome, Just One. Your account has been created. And one of the things that we really tried to emphasize with this flow is making it as user-friendly as possible. So I just created an account, but I only set my username. So what? So we included this kind of like helpful message here. Wait, what's my password? You don't need a password. Web Native SDK demo uses public key cryptography to authenticate you with this device. Brian, do you want to pause here and walk through kind of what's happened?
Yeah, that's a great idea. Let's take a look in the network tab.
Sure.
And do we have? Did we? Perhaps we should have had the console open earlier to capture that.
No worries. I can make that happen. We'll go to application and clear these out real quick.
So what Jess is doing is a lot of the app state is stored locally through Web Native. And he's going through and deleting all of that state so that we can get a fresh start and have the network tab open so we can, kind of get a better look at what happens.
All right. How about Just Martin 2?
Let's do that. Yeah.
Register. Right. Now over to the network tab.
And go ahead and take a look at the user request. So you can see that we've done... well, go ahead and go to the headers for a moment. We've done a put request, and back to the payload. You can see that our username. Could you click on the payload again? You can see that we this was the username that we requested, and then looking back at the headers, we made this request to a Fission server. So we're registering as Jess Martin 2 with the Fission server. And creating a database entry for this username. And the other thing that we're setting up is a decentralized identifier, a DID, for Jess Martin 2. And you'll notice that we didn't have the DID in the payload. So like, where's the DID, right? The DID is actually inside the UCAN, which is the bearer token that we see down here below.
And Brian, can you say a little bit more about what is a DID? Because that was one of the like acronyms that when I came to Fission 7 months ago, however long it's been, was just assumed that you knew what that meant. So what is a DID?
Yeah. I just saw the comment from Yuri. Hi, Yuri. Yuri's been along with us for a long time at Fission. We've made emails optional. So a DID is a decentralized identifier, and it's basically an identifier that's based off of, it's derived from public-private key pair, an asymmetric key pair. We actually derive that from a key pair that we've already created here in the browser using the Web Crypto API. So we can take a glance at that. Jess, if you want to go to the application tab.
Do that. Over here in application.
And go ahead and expand that first entry and key value pairs. So you can see that bottom entry there. We've got a right key. This is the user's key pair. And they have a private key and a public key. And if you want to expand those, you can see these are RSA keys. You can see that the private key is extractable as false. And so this means that only the browser can access the private key. It's shielded, like JavaScript is not able to access that at all. And so it's secured like at the browser level. And we can make requests to the browser to say, please sign this thing, or please, encrypt this data. But we can never actually directly access the private key.
Is that a function of the Web Crypto API? Is that what
it is?
Okay, cool. So that's
when you create Web Crypto keys, you can specify should they be extractable or not. If you go to crypto key, there's a little bit more information there on the type, and you see there's an extractable property. Should it be something that can be extracted or not? And clearly private key we don't want it extractable. Public key we do. And the DID, part of the DID, the decentralized identifier, is the key, is the public key that's been sort of prepared according to a special way. It's actually like tacked on to the end of the DID. A couple other things to point out here. You can see that the we have a usages
Mhm.
array. So the private key, in this case, can only be used for signing, and the public key can only be used for verifying. And that's sort of a best practice, that you don't want keys to be used for signing and verifying and encryption and decryption. You want to have like a separate key pair that handles your encryption. And entry 4 there,
Mhm.
if you want to expand that. This is the key that we use for encryption, and you can see it's a symmetric AES key.
Mhm.
It is extractable, and you can see that its purposes are for encrypting and decrypting. It's extractable because we use this key for encrypting the private files in a user's web native file system. And we need to be able to pass this key between different devices so that they're able to decrypt their data when when they link
Interesting.
another device.
So a summary statement of all the things we've been talking about right now is when you create an account with Web Native, you are basically giving the user's browser the abilities or permissions it needs to be able to do all of the things. And the way that works is there's a key that the user now has in their browser that they can use to basically sign messages that can be verified as like coming from them. So they can basically say, when I take an action, I can promise it's me, because I'm the only person that has this private key, and only this public key will only decrypt this private key, or there's that matching there. And then similarly with the encrypt decrypt, right, of like, you have the ability, your local browser has the ability to like make a file private or make a file public, encrypt it, decrypt it. It's not that you have to go to a remote server where you're like uploading through a post, through HTTPS, hopefully, so it's secure, and then that remote server encrypts it for you, saves it to a file system that's not your file, that kind of thing. You actually have all those abilities locally because the keys reside in your browser.
And to put a point on that, this is end-to-end encryption, right? Like the user is encrypting their data here locally, and even Fission cannot access that data.
You said something that raised a question that I wanted to ask. We don't have passwords. I love that. We don't have emails. We're not storing the email. Why is there a server at all in this case? Why are we doing that put to run fission.com?
Yeah, so we have a server because users want to be able to access their data not just on a single device, but across multiple devices. And oftentimes they want to like share a file publicly. And so Fission does the hard work of running a bunch of IPFS nodes so that the data is available, across the web and, in different places where a user might want to get it. And so there has to be a server component at some point, just, because it's not, we're not in a purely like P2P world.
Yeah.
I
guess I would say, Brian, I would say that I think the reason that there's a server is because there are limitations to the peer-to-peer networking capabilities that like modern browsers and the internet has right now. Is like the summary statement. We could talk about what those limitations are, but that would be one. And then, as you mentioned, Brian, like Fission provides like known IPFS nodes that you can like send your files to, which is really helpful. But those can be swapped out, right, Brian? Like those are configurable. Like you can say, go to these other IPFS nodes, not
sure.
Fission's.
We do that with our staging infrastructure, like production versus staging IPFS nodes. Yep.
Would it be correct to say that that is a little less worrisome if it really is just IPFS because of content addressing, that at least you know what the content is that you're fetching? Like there's some verifiability there.
Yeah. So the content, if you're, Chad, I'm not sure how familiar you are with IPFS, but every piece of content, you can get a content identifier, a SID, for the content to know that it is indeed, it hasn't been messed with or played with or tampered with, I guess would be the right term. And we'll show as we go a little bit further on in this, maybe not today, but that you can indeed, when you store a file on WinFS, you can indeed access it from other IPFS nodes. We'll show looking at a file on Fission's IPFS node, and then that you can go to one that's run by Protocol Labs, and the same file is available there.
Cool. Pretty cool. Yeah. The other thing we use it for, though, Brian, and this is something that we're actually talking through how we might further decentralize this is for names. So notice I've got a Jess Martin 2 is a name that I was able to pick and basically associate with my public private key pair. And that's really handy. We could like another way that this could be handled where you wouldn't need name servers at all is you could create the local like public private key pair locally, and then you could like use the did, this horribly long string that means nothing, 200 characters of garbage as your name on the internet, and then no name servers needed. But generally people like to be able to log in using a username. And so this is more about ergonomics than any sort of security concern. And then the other way of saying point around that is that the Fission server itself is open source. So if you wanted to run the Fission server yourself and have it be running on your infra and run the name service that we just referenced and run your own IPFS nodes, you can do all of that if you want.
Quick question.
Yeah.
Chad, does that answer your question?
Yes, thanks. And then Yuri had a question. Can I configure it to use my local IPFS desktop or something? That's an interesting.
You need to be able to reference it via HTTP, I believe.
Yeah, it probably would be possible. You'd have to. You probably would need to be running the Fission server locally to have control over the peers, and there might be some funniness around certs and whatever, but maybe. But you mentioned the did being like super long. Maybe that's a good segue to take a look at that UCAN.
Yeah, let's do it.
Okay.
So that would be over in the network tab, like you were pointing out when we jumped over to look at the keys. There's this user request, and part of the header that gets sent. And this is where you jumped there, Brian, is because we actually send as part of the request, right? The headers part is coming from us to the server, not back to us. Back to us is the response, and the what we send as part of the headers is the did. And so is this whole thing the did? Brian?
No. So this is a UCAN that's authorizing the server to create an account on our behalf.
Okay.
And if we inspect that and pull it apart, then we'll see that the did is in there. So let's grab that, and I think we have in VS Code we have a way to take a look at that.
Yep. Let me open a new file in here, just save it to desktop as something.json, and then paste this in. And I think we have like a base 64 decode.
Oh, hold on. Actually, go back.
Oh,
go ahead and break that into 3 lines on the period, so you can see. You've got 1 period there on the second line, and give us some new lines there in between them, maybe just to have a little bit of space. So this is a UCAN dissected a little bit and broken into 3 parts. At the top, we have the UCAN's header. And so if you want a base 64 decode that, we can take a look. And you can see that there's the algorithm. So don't do the last one. There's the algorithm used for the UCAN, that it's a JWT. It's actually just a JWT. And the UCAN version. And one thing I'll mention, actually, before we go too deep into this, the Fission server and Web Native still use a fairly old version of UCAN. It's actually, the version there says 1.0, but it's actually, we've changed that field to say UCV, and it's actually, what we're looking at is UCAN version 0.3.0. And UCAN as a specification has progressed quite a lot since we initially implemented these parts, and we haven't gotten around to upgrading our server and Web Native and everything to like use the latest UCAN. So folks who are already kind of familiar with UCAN may say, wait, what's all this like RSC and PTC and this kind of stuff? Okay. So this is UCAN.xyz is the community UCAN website that has like an introduction to UCANs and has it's just like one version behind. We have this tool for like encoding and inspecting UCANs,
right?
But we're kind of like looking at like old UCANs that we don't support in that UCAN checker. It's just Fission that's using them. Nobody else is using them. So anyways, the first section was our header, and then we've got a payload. And you can see the issuer here. It starts with did key Z13, blah, 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 blah. This is the user's did that's associated with Just Martin 2. And it's been derived from the public-private key pair that we looked at earlier in browser storage. You'll also see an audience up there, which is a much shorter did key. That is the did of the Fission server. And so if you look a little bit further down, we've got a PTC, which is a potency. What can happen based on this UCAN, what's authorized is an append, and RSC is a resource. And so that's basically enough permissions to say, hey, server, create an account for the user with this did. The expiration, I mean, we could look at a Unix time inspector, but it's basically, it has already gone by. It's like this token is valid for 5 minutes, basically. It's just enough time to authorize the server to create the account. NBF is not before, so that's like, you can't use this UCAN until it's essentially the time at which it was created. PRF proof is something that will become more important a bit later when we look at another UCAN, when we're linking devices. Proof is used as, you can nest another UCAN inside of a UCAN to create a UCAN chain of proof of authority. In this case, we just created the key pair. We need no proof. This user has root authority to do whatever they want to. I guess
because it's their key, right?
Because it's their key pair. Exactly. That's right. Yeah. Maybe the other thing that's kind of interesting to point out too is that you notice the issuer's did is quite a bit longer than the server's did. The issuer's did is based off of an RSA key because and then the audience, the server's DID is based on a ED25519 key. The browser does not support ED25519, which is why we still use RSA keys in the browser.
Interesting.
So, yeah. And then the last piece down below the payload is the signature. And the thing that gets signed is the base64 encoded header, period, base64 encoded payload. And so like all of the information that we're sending is signed. And remember earlier that I said that the issuer has the user's public key in it, in the did format. So when the server gets this UCAN, it's able to extract the public key and verify the signature because the public key has come along for the ride in the UCAN. And so UCANs are self-certifying, and you don't have to do the whole game with public key exchange and where did you put your public key and blah, blah, blah.
Interesting. Okay.
Yeah.
Having done some stuff with JWT in the past, like anyone who has, I guess, will recognize a lot of this. And it says type JWT. Is UCAN a superset of JWT? Is that the right way to say it?
That's a good question. I'd say, I don't know if superset or subset would be correct. It's a limited set of fields, some of them which are already defined in JWT, but some that are added special for UCAN.
Okay, cool.
Yeah.
Great.
Cool. So that was the process of signing in. And again, like you're at step one of, using the Web Native App template. You created an account. You have a public private key pair and an encryption key pair stored in your browser. And the account has been created, and you sort of have a file system that has been created for you, which we'll talk about later. Now, the problem with this scheme is that key actually lives in this browser, not on my computer. If I open Safari, Safari does not have permissions. If I open another profile in Chrome, it doesn't have permissions in the same browser, right? And so you're really locked into this one browser being authenticated to do everything with the application. But if you uninstalled your browser from your system, dropped this device into a volcano, as is a common example, and because of public-private key cryptography, you're never getting that account back ever. Like Fission can't recover it for you. Like you're done. The private key is gone. And so what we do after you get past this continue step is we encourage you to link another account. And so we immediately kind of prompt you, back up your account. Your demo account lives on your devices. You can skip. We kind of discourage it. Are you sure you want to do that? You can click YOLO. I'll risk just one device for now. Or you can click a connected backup device. And this is one of the parts that we worked really hard to make easy, because we want to make the right thing easy. And the right thing is to connect the second device right away. And so you have a QR code. I could scan this and go through this on my phone, but obviously you wouldn't be able to see that. So I'm just going to do it on a second browser real quick. Let's see, Safari, bloop-de-doo, quick share connection link, come over here, and then go ahead and open the inspector on this side too, because we'll get some creative stuff coming through there. All right. So you notice that once this loaded, we had the digits, and if I type them in, as soon as I finish typing them, you've connected a backup device. And then on the right-hand side, it's doing and instantiating the file system as well. And hopefully it works.
You've already used your one mistake for the session. So.
Yep, I know. Yeah.
No. We have a second one.
Maybe Brian has to take credit for this one, and the next one will be me.
I do.
Hopefully we're good. Let's see.
This is a really nice user experience, and it feels like you're taking all this public key cryptography stuff, which is outside the reach of most users, and you're doing it in a way that is no harder than like using an Amazon Echo or a Fire TV or something. You know, people are starting to get used to this flow too, I think, from devices.
Yeah. So you're connected, Just Martin 2 on both sides.
Hey.
So we probably lost no, we have the network stuff. So we can still see what happened on the right hand.
Yeah, in this case, the network stuff won't help us as much because this happens, but we will want to look at storage, which in Safari is called storage.
Yeah.
And if you want to expand Fission, WAT,
sure,
little partway down there. And then maybe do the same in Chrome so we can like take a look and see how they compare.
Yeah. So before we get into the how this works, what has just happened?
Yeah.
I was just going to summarize. What has just happened is this browser on the right, my Safari browser, now also has the keys it needs to act on my behalf as a user. So I've authenticated or authorized this browser. I like the way Brian put this yesterday was really helpful for me. We're still debating this terminology because describing this it's different than usernames and passwords. And we have like years and years of decades really of experience in describing that sort of authentication scheme, but not as much with this. And the way Brian described it is you can almost think of these browsers as like agents that can act on my behalf of like, yep, I've given that browser my key and I've given that browser a key for me and it can do stuff for me now. So we
can take them back.
But how did that happen, Brian? Like we already talked about how you can't export the private key. Right.
Yeah.
So even if we wanted to do something really stupid, like send a private key across the internet, across the wire, you actually can't do that. And so what happened?
So what's happening here is pretty much entirely authorization. In Web Native, there's just very light bits of authentication here and there, like when we in a sense, like having a key pair is like authenticating it because the user is involved. But like when we link from one browser to another like this, what we're doing is we're authorizing from the agent in Chrome to a new agent that we create in Safari. And if you compare the storage on both sides, maybe do you want to on Chrome see if we can, yeah. You'll see that on the right side, not only do we have like the right key and some of those other keys we looked at before, but we also have an account UCAN up there at the top. And this account UCAN is a UCAN where the agent in Chrome has authorized the agent in Safari to act on the user's behalf. Jess, did we find a way to copy this one so that we can inspect it?
Oh, yeah, we noticed when we were going through this one time, we realized that it's impossible to copy out of the inspector. If you copy the rows, you get that weirdness.
So what would you think about could we link this account in Chrome to another profile?
Totally. Yeah, I've got it. Let's see.
Yeah,
profile. We come, and I mean, this kind of shows off another kind of cool feature, actually. Oh, one of the things that I'll do before that, just because it's fun. We built into the template is the ability to set an avatar, and this actually saves your avatar to IPFS. So I'm going to go do that real quick. And that should take just a second and update right there and there. Cool. Now I have an avatar set. And then also here, I can connect an additional device. So that takes me back to this screen. You could connect, 2 phones, a couple browsers, however you want to do this. Connect your desktop and your Mac and your laptop. So I'm going to go do that on the right over here. And we're going to go through that same flow. Let me make sure I open the inspector first. So that we get...
Or anyone watching could connect their phone, right?
Yes, exactly.
If they grab the link fast enough.
Go. Oh. Uh-oh. It's not picking it up on the left over here. Let's see. Being cranky today.
Do you want to close down Safari? Make sure we don't have any open channels.
Yeah, that could be it. Okay, Safari's now quit.
Okay.
I might be jumping the gun, but a question for you while you're looking into this.
Do it.
We've authorized Safari. If someone steals my computer, can I then kick that one out?
No.
Okay. Important to know, right?
Or
not currently.
Another way of saying it, not currently, not yet.
Yeah.
That's actually one of the interesting things about the scheme is that the root user could revoke authentication for other keys. So the root user right now is the Chrome, or is this Chrome browser here. So technically it is possible. There is no facility for that right now.
Yeah. And one of the ways that you can look at doing that is, I mentioned we have this account UCAN. And so on the server, you could take a hash or get a SID for this account UCAN and invalidate it server side and say, I'm not going to honor requests when this UCAN is used as a bearer token. So yeah, technically possible.
Yeah, and when you do that, an important thing to mention that didn't click for me until fairly recently is that when you're revoking an agent, you're saying no future rights for you, and when future changes come in, you won't be able to read them. But all of the changes that have happened while you were authenticated, you can still see all of those. Right. So you still have read access to everything up until the point where you were revoked. And then every right after that, you can't see. And so there's this, which is technically the case, the way that everything works right now, right? Like if you're authenticated to a service, you could download all the stuff. And then if you get kicked out of that service, well, it's still on your local machine. There's nothing they can do to take it away from you. But it is somewhat counterintuitive of based on username, password auth. So
we often refer to it as the screenshot problem.
People can always take a screenshot and just hold on to it.
All
right, so I can copy this one. Thanks, Chrome.
Yeah. Before we dig too deeply into it, one thing to mention about this account linking flow, what we do is we bootstrap an encrypted session between both sides of the exchange. Aside from doing that automatically, you notice that we had the PIN verification. And so we have one human factor in there to prevent man in the middle attacks. Oh, by the way, this is the Awake protocol, which is folks want to learn more about it. It's over in the UCAN specification. Do we have it there?
Yeah, there's a link to it.
Yeah, totally. Once we've set up an encrypted session, we're able to exchange secrets over it. And the secrets that we exchange are this UCAN that we're going to look at, which authorizes the second device, and the read key or the encryption key that allows us to decrypt parts of the private file system.
Mm-hmm.
Yeah.
And to that point about bootstrapping, right? A server is used to help the peers find each other. But once the peers have found each other, they set up a direct connection to one another. And so these two browsers are talking directly over an encrypted channel, no server in the middle.
Right. We use WebSockets, and the server is just a proxy. It doesn't do anything and doesn't get involved, and it doesn't even have access in the encrypted session once that's set up.
Mm-hmm.
Yeah.
All right. So why am I getting this account UCAN? What is this, Brian?
Okay, so this is the UCAN that has authorized our second device to be able to act on the user's behalf. And we can compare. The left side doesn't have one.
Not one on this one side. Yeah.
So the browser where we originally created the account has root authority, and it does not need to be authorized by anyone to act on the user's behalf. This is like where we all started. But the second one, if you want to go ahead and grab that and we can take it apart, we'll see that it's a bit different. And the first UCAN that we looked at was an interaction between the browser and the Fission server to register the user. The second UCAN is a little bit different because it's from one browser to the other.
Okay. I think I got it.
And one thing that you were mentioning, Jess, earlier about sort of like account recovery and having this as a backup option, this UCAN is going to authorize the second device to act on the user's behalf with full authority. And we could look at the time just for fun on this. I think it's like 100 years or something like that. So that if the user did happen to lose their other device, then it kind of doesn't matter because they have another device that has the same level of authority. And the server will be able to look at the nested UCAN at the proof that we'll see momentarily to verify that it was authorized at some point. So are we?
Did I copy the right one? This doesn't look right.
Yeah, it does look.
No, it is. That is right. Because it doesn't have a proof.
It doesn't have a proof. Exactly. I think that it should have a proof. So what's going on there?
I'm not sure.
All right, this is the third I'll claim responsibility for that.
Well, technically, just because we don't know what's going on doesn't mean that there's actually a problem.
Also, we just refactored quite a bit of web native, and so we might be looking at the wrong UCAN.
That is possible.
Do you want to? Why don't we grab that permissioned UCAN down there below, and see maybe. There's a couple of them in there, huh? Okay.
No, it's just the way I'm having to do the copy. I'm working around the limitations of Inspector.
There was a separator there. There are multiple.
Yeah, there was a separator. I think that it's encoded to have a couple of them, but we'll see the separator, I think.
So this is the permission UCANs. Oh, and it is plural, so we'll see. All right, there's one. And
you have 3 pipes that's separated.
Oh, what were the pipes then? Right there?
Yeah, line 39.
Oh, okay, cool. So yeah, you're right. So permissioned UCAN 2. Stephen, by the way, in the chat just said it shouldn't have a proof, I think, because you're issued from the root key pair. You'll have a proof when you link again. Okay.
Oh, okay.
I would say Stephen is the expert here.
Yeah.
So we still have one mistake we can make.
Okay.
I'm going to use that just to ask questions so stupid that they count as mistakes.
Well, now, Chad, what you've incentivized me is to bring more people to my live streams because it ups the number of mistakes I can make. Oh, wow. Yeah, that one's definitely longer. Interesting.
Yeah. Okay. Well, we can
Permission.
we can maybe based on what Stephen is saying, we can look at that first UCAN as a starting point, and not worry about these permissioned UCANs for now. So the yeah. So you can see that the issuer, both the issuer and the DID are the super long DIDs, right? The ones that are based on RSA key pairs. And so we can tell they're both from browsers. And if we look at the issuer there on line 22, the last 5 characters are Yu Zhang. And if you want to scroll up to our original UCAN and look at the issuer, Yu Zhang.
Yeah.
So we can see that that is indeed the initial browser that's issuing to the audience, which is this second browser that we've just linked, right? And then do you want to grab that expiration and maybe open a Unix time inspector or something like that? And we can...
It is 3008.
Okay, yeah, so much more than 100 years, plenty of time. And then the last 2 pieces in there are that the potency and the resources are super user. So this UCAN can do everything that the original device was able to do on star, which is a wildcard for any resource. And so this is a rather powerful UCAN, but it's only powerful for this device that we've linked, because the device that we've linked is listed in the audience. And so when we make a request to the server, then we'll take this UCAN and we'll create a new UCAN and we'll nest this UCAN as proof when we send it to the server, and the server will take a look through and make sure that everything lines up. So you could, in fact, take this UCAN and post it in public, tweet it or toot it or whatever your preference is, and no harm done. It's it can only be used by this device.
Okay, it's time for my stupid questions then. So we're exchanging these UCANs that are declaring permissions for the new browser, the sort of delegation thing. Who's going to check those? And like, what am I know I'm allowed to do everything, but what does that even mean?
Yeah. So these will be checked when you want to add files to the file system. That's probably the most sort of commonly used place. And we do have an app that allows you to like publish other web apps from within the Web Native SDK. So that would be another place where you would be able to use them. Any other spots, Jess, that you can think of?
I'm thinking, well, the important...
It could be a conceptual question too, so it doesn't have to be things that exist now,
Right.
Yeah.
And that I think the important thing is that these keys, I mean, the read-write keys are really important, because that is each time I store a file in IPFS. So for those of you who are not familiar with IPFS, decentralized S3 basically, and by default everything is public. Like if you store a file in IPFS, anyone can see it. There's this content addressing magic and that kind of stuff, which is really neat. But if you want a private file system, you need to encrypt those files yourself before you store them on IPFS. And WinFS, the Web Native file system, handles all that for you. And so having a key pair that encrypts those private files so that they can be stored on this giant IPFS network, and then you can actually decrypt them later. Actually, how would that work, Brian? Because there's a separate encryption. The read-write keys over here are different than they are over here.
Well, no, they're the same key. in this case. You're looking at line five on the left and 6 on the right.
Got it. So these keys
yeah.
are the same. That's why you were saying they're extractable. Of course.
Yeah,
Gotcha.
and that's one of the secrets that we sent when we did device linking. And just as a sort of side note about the file system, when both of these browsers have access to everything in the user's file system, it's like a root permission. We do have an API that currently only works with the Fission auth lobby, but is something that we're looking to implement in the future, where one app can go to another app and request for permissions for just a small portion of the file system. And you can kind of restrict access to just like bits and pieces. And when you do that, you actually end up with different read keys, because the read keys are kind of like, think of it as like a tree of boxes. And you have a box at the top that can be unlocked by the root sort of encryption key. And if you unlock that and go down to another directory level, there's another box, and you need, and that has another key in it. And you can, if you happen to have the key just at a lower level, you can unlock lower levels of the hierarchy as opposed to the entire tree. Yeah. But for this app, it's just every time we link a device, each device has access to the entire file system.
Yep. No, that makes sense.
Yeah.
Any other genius questions, Chad? Does this all make perfect sense now? You understand UCANs and can explain them to a 6-year-old, right?
Almost, yeah.
Almost.
Yeah. Who I need to explain it to is the person who has a users table in their Postgres database and a roles table, and then some mapping of roles to things you can do.
Yes.
And that model, it's, obviously the server is just looking stuff up and making decisions. And so this is a different way of thinking about things, obviously.
It really is. And the having worked in on systems that have that roles table, and just the complexity and the all of the application code and checking, is this action permissible for this role? Is this action permissible for this role? And then deprecating roles, oh my goodness, or adding new ones, it ends up being quite the mess. And this feels a lot cleaner in the sense that you're given a read key, and if the read key can decrypt the thing, then you can do the thing. You can have the thing. Yeah. If it can't, then you can't. Period. And so the way I like to think of it is like, instead of roles and like all this client code and that kind of stuff, is basically like a ring with keys on it. And you've had that experience where you're like, I'm not sure what this key does. And so you're like trying it in different locks around your house. That's basically this model of like, you just try the key, and if it works, then you can do it. And if you can't, then you need to handle in your application code, you only need to handle the case where the key is no longer valid. And you don't have to check on all the roles. If the roles table ever changes, that's fine. It doesn't, like, there's none of that. Like, you don't have to worry about that. It's just, does the key work or does the key not work? Period.
Yeah. Well, if we're satisfied with account linking, should we start building the app?
Yeah, let's do it.
All right.
Cool. So I think hopefully now you have a decent idea of how the web native app template works in terms of what's going on under the hood when you click through and do the auth. It's not essential that you understand how it works necessarily, but it is pretty different from the way that we tried to make it look as close to what you were used to as possible. But it's actually quite different what's happening under the hood.
And maybe it's good to come back and emphasize again why this is passwordless, is because it's all based on different agents acting on the user's behalf and key pairs in each device, and the user is fully in control of which devices get linked. So yeah.
Yeah, Yuri keeps using the word player instead of agent. Kind of nice, I think.
Mm-hmm.
Yeah.
And also, here's a thing that I said to mention. I'm just enjoying showing comments on the screen.
Do mention that the web native apps ask the player permission to access specific portions of their file system. Absolutely, and this is what Brian was just referring to, is that you can build a web native application in such a way that it goes to the user's file system and says, can I have access to just this directory or this directory and this other directory? We've actually implemented that as part of our the lobby experience, and it looks very much like when Google says, do you want to give this application access to your email? They're going to have permission to do reading and read your contacts, but they will not have permission to send email on your behalf. Do you want to do that? Yes or no? And you can click authorize. And so you get that same experience with UCANs, and through the Fission lobby enables that. So, well, let's jump into building some stuff with the Web Native App Template. So I mentioned that the Web Native App Template, the CSS and HTML is very customizable, but just about everything is pretty customizable here. And so if you go to the README, you'll see that there's like steps in here for renaming your application, customizing the logo, customizing the look and feel, which I already mentioned, and then clearing out the homepage, removing the image gallery, demo app code. So it's really quick to kind of like strip this thing down to the bare essentials and then build it up into something that you can really make your own. In fact, I'd say for most people getting started, start with the Web Native App Template. Don't start with the Web Native Library directly unless you're very familiar with Web Native Library already. It's easier to take this Web Native App Template and tear it apart. We've designed it that way. And start from there than it is to start from the Web Native library and your own random application. And so I'll demonstrate that right now because we're going to build a contacts app, or get started on one anyway, since it's already about an hour in. And I'll just demonstrate a couple things real quick. Over here on the left, I have my application open, and we're using SvelteKit, so everything's organized into like these source routes. They have basically file system based routing. And so one of the homepage right now has all this stuff about a photo gallery demo and a device connection demo. You can actually click over here and see the photo gallery demo that gets included, but we're not going to be using that for a contacts app, so we want to get rid of it. That's as easy as coming in here, right clicking and deleting the gallery folder. Now that's gone. The problem is we still have this link that takes us nowhere. With a very nice 404 page. I don't know that I've ever seen that 404 page.
Oh yeah, yeah. That's using Hydrosynth, I think, is the library that gives us that cool animation.
That's awesome. All right, but you don't necessarily want the user to see the 404 when they click the button, and you don't want this necessarily on the home page. So we're going to go through and delete that, which I think gallery is in the auth page. That's right. Reveal and explore review. So in the home directory, you'll find an auth and a public. Auth, hopefully, obviously, shows what is in what's on this page after someone has already been authed, and public shows before the user has been authed what's on the page. So we'll leave the welcome username and then delete the rest of this stuff and hit save. And now we've got welcome Jess Martin 2. Let's go over to the public as well. Not that we're going to see that again today, but I'm going to delete this whole block here, which had all the information about Web Native is, passwordless, yada, 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 yada. I'll also go show, I can go ahead and over to the app info where we define a lot of constants. This is also kind of nice. I can come in and change the app name to contacts demo. And then over here on the left, that should change. Where would that change?
Up in the title on the tab, for one.
Oh, yeah, there we go. And the title on the tab. And then on the home page, when you're logged out, it shows the name of the application. So like, welcome to Contacts Demo. Let's see. So Chad, it's up to you. How much further do you want to go on this? To give you a sense of where we were going to go, we were basically going to build a little contact form and have that write V cards to your file system. So you could like save private V cards, come in, type a name, an organization, that kind of stuff. V cards is a standard that's been around forever for contacts. And then you could see that V card on the IPFS network on different nodes, download it from anywhere, that kind of stuff. So it's a tiny little contact management app.
How far do you think you can go in, let's say, 15 minutes?
We could probably get V card saving in 15 minutes. We couldn't explain what is happening. but we could probably get it done.
You type fast, Brian can speak. How about that?
I like it. All right, sounds good.
I'll just laugh when you make a mistake.
There you go. And count the number of mistakes we have. That's a very important role too. You're doing an excellent job of that. Excellent.
We're up to like 2.5.
I'll also just add people's comments from YouTube randomly on the screen.
What is half a mistake? That doesn't even make sense.
One thing that I will notice that we kind of glossed over a little bit is you can see on the right on the link device that we have Jess's avatar. So we've already used the Web Native file system. When we uploaded it in the original device, we put it into the Web Native file system. And then when we linked it, it went and got the user's file system from IPFS, and the avatar was already there for us to display. Oh, Acme, nice.
There we go.
Okay.
Cool. So we talked about earlier on the stream, we definitely don't want to sit and watch me write CSS and HTML. So I went ahead and prepared this ahead of time and copy and pasted it in. And so what it is, all of this like mess that you're seeing in the class, these class declarations, all that's Tailwind. And it gives you some nice stuff in terms of like setting text sizes and stuff. So it was really easy to build this little bitty form, but still you don't want to watch me do that live. So copy pasted that in. Right now, what we've got is a little Svelte component that has a name and organization field, and then there's a name and organization variable that is bound to that. So if I say Jess Martin and save it, it'll reload the page and the name becomes Jess Martin. Similarly, as I come in and type in here, the way this bind on line 20 works is that this variable is being continuously updated, which is kind of nice. This a good SvelteKit makes a lot of these things a lot easier, at least to my mind, than React. So we now have we'll just do name and organization since we're like trying to hustle to actually getting a file saved to the file system. We'll add more fields later and make this more robust. But what we'd like to do is like be able to generate see the V card that we're going to generate and then like save it to Web Native file system. So the other thing I did, which is like one of the most unpleasant things to do on a stream, is find a library that implements something that you want to do. Gosh.
Yeah, so you download it, you install it, it doesn't work, you go to the next one.
Exactly. This one hasn't been updated in 1 year, but this other one hasn't been updated in 2 years, but it has more dependencies. Does it work with ESM modules? Does it work with TypeScript? It's just, it's such a hassle.
So I have random stuff on the global scale.
So we're going to do that now, right?
Yeah, that's how we're going to spend the next 10 minutes. Buckle up. No. So I found one, thankfully, and hopefully I can.
VCF.
Where is it? Card VCF. Yeah, thank you. You said it. I was just not listening. Yep. So let's go over here to open a thing and say npm install VCF, and we're going to save it as a developer dependency. All right, that adds it in for us, and then I'm trying to remember how to include VCF. See, I think it's auth is where I was doing this stuff. VCF. Public. There we go. Import vcard from VCF. That's another annoying thing about JavaScript is you actually don't know what the export is unless you go like read the docs or look in the library itself. So that gives us this thing called vcard, and vcard can be used in the following way. I can grab or I can create a new card saying let card equals, what was it? New v card. And then there's a really simple like get or like set API for this particular library. So what we'll need to do is I'm going to create a function here called update vcard, and Copilot's going to guess that that's what I want to do with it, and it's not wrong. Yeah. And so the other thing I've got going on here is when the value changes of that name, it should update the vcard. or it should update. It should run update vcard, which will then set those things for me. And I'm trying to remember. I think it's card to string. You got that one wrong, Copilot.
I haven't used SculptKit before, and I'm sort of inspired to play with it. This is really
Oh,
simple.
it's so nice. It's the first thing since I left Railsland that I actually liked after like several years of toiling in the React mines. Let's see. So now if I pop up on console, hopefully we will see a console message when this changes. Hey, what do you know? Begin vcard version 4.0. And each time I change it, I get a new console log. So sweet. So the other thing we could do, I haven't added the bind input down here on this organization field. So I'll just add that right there, which will now make the same thing happen as I change the organization. And then the only other thing I thought might be nice is just showing the vcard in the UI, the vcard format in the UI. So I can do that again with another bind value. So I'm going to say bind the value of this text area to, let's say, card or vcard string, maybe. That doesn't exist yet, so it's going to blow up on me. And so I'll click here. What's that?
Looks like you lost a closing quote on the line above that.
Thank you. I'll set this here and then go take care of that. Thanks. I'll set that to empty string for now. And then you're right. I lost a closing quote. All right. So that's now bound to the value. So now when this updates, we will update the vcard string to string 4.0. All right. And now when I do this, it automatically, I guess I don't need a generate vcard button because it does it automatically. But now it's cool. Like you can actually see the vcard in the UI, and it updates really, really fast and feels really good. So yeah, that's one of the reasons I like Svelte. I mean, this tiny amount of code and a tiny amount of like inserted into this special sort of HTML. One of the things that's nice about Svelte, just to prop it one more time, is that they try to use as many of the browser APIs as possible. And so when it's possible to just use like native browser stuff to do stuff, they do that instead of like building out the entire sort of shadow DOM and that kind of stuff that React and other frameworks had built out.
We should have put Svelte on the description too. This is worth tuning in for me.
It's been fantastic. All right, so I think the next thing is like save vcard to IPFS. And this is where Brian's going to tell me what to type. I kid.
Okay. So I guess the first thing to look at is do we have a handle on the file system here in this component?
Definitely. I think that would be in the file system store?
Yeah, exactly. So we're going to have our file system store there. So yeah, go ahead and import that.
Is this coming from something that was generated in the template?
Yeah, exactly. Yeah.
Yep.
And then I think that we're going to. Is it guessing what it is?
Wrong. Copilot is not very smart about web native yet. We need more sample code to trade it on. But.
So in Svelte, there's a few different ways that you can access stores. You can access them with a reactive binding. Maybe we want to take a look at how we do this with the avatar.
That's a good call. That would be in settings, I believe. Yeah. No, that's the icon. We want the actual component account settings. There it is. Oh, that's the lib. That actually might be where we do it. Let's see.
Oh, okay. We're doing this in a TypeScript file, not in.
Yep. Okay,
gotcha. So we've kind of like abstracted it into function call.
Yep.
So we could implement it as kind of like a function that we call to add avatars, or we could try to work directly with the store in the Svelte component. What do you think?
Yeah, let's just do it in the Svelte component. I think we'll need a directory.
Yeah. Mm-hmm.
Looking at this code. So this creates the path, or creates the directory, or like gets a handle on the directory. I'm not sure what this does.
This is linking.
List.
This is listing all of the items that are in the
directory. Looks to see whether there's an old avatar. If there is an old avatar, archives it, and then, yep, moves it to the archive directory, and then writes the new one. Oh, this is archive old avatar. I guess I should just read the title of the function. And then there's get avatar from WNFS, and I bet there's going to be a write avatar right here. Yeah, upload.
So just to clarify, we're looking at this stuff as example code that will show us what to do for the V card, right?
You got it. That's exactly right. We're going to steal some of this code. That's one of the nice things about having a fully functioning application, Chad, with like the web native app template, is you can go digging around in this repository and find example code that you want to steal and use to build your own app. So yeah, we basically want to do something very similar to this.
Yeah.
Started at WinFS.
So why don't we create a TypeScript file in the lib directory for handling vcards.
Sure. vcards.ts. And we can even grab this whole function.
Yeah, good idea.
And then customize it. So yank, paste. We would need.
Grab the imports.
Yeah, you're right. There's quite a bit more than we'll need.
Yeah.
But one of the nice things about VS Code is it will tell me which ones I'm not using, which I'm not using those. So I don't know if you noticed before I deleted them, they were grayed out. So that was handy.
Are you using VI editing mode here?
I am using VI editing mode. So yeah, I'm using things like Shift V and J and K to select lines and DD to delete and things like that.
Congratulations.
Yeah. All right. So we don't care about archiving the old avatar. We don't care about file limits. We also don't care about renaming. I'm going to delete that too. We basically need to. Oh, interesting. That's kind of fun. They have a loading state when you set or when you start saving it. So we could do that. We'll leave that in. This gets the file system store. The next thing creates the subdirectory and adds the V card. We'll do that. And let's just make up a file. Any ideas? Trying to remember what the avatar dir thing looks like. So account settings dir. Oh, we need private, comma settings, comma something. Oh, that's if we wanted it to be settings.
Yeah. So let's think about like two questions, Jess. We want to save multiple different V cards, right? Are we doing just like one V card?
Yep. We're doing one V card.
We're doing just one V card?
You got it.
Just for today.
Gotcha. Just for today. Okay, got it. Yeah.
This is a personal V card publishing system. You can write your personal V card and publish it to IPFS. That's where we're going to get in the next minute or two here.
Let's take a look at Is that going to do it?
So yeah, just a couple things like to try to explain the code that's going on. This thing adds a loading state using Svelte's stores, and that will like transition the UI to like a spinner. This allows me to get the file system store, which has a handle like a pointer to the file system, and that's this little FS thing that we need. And then that FS is basically WinFS, like Web Native File System. And once I have Web Native File System, I can do things like write. And I can get a file or a path within the file system. So this is basically saying take private /vcards/mycard.vcf. That's where we're going to save the file. And then this file to uint8 array. Every file that's stored in the Web Native File System has to be in a uint8 array format. So we need to convert it before we upload it. And then the fs.publish is where we tell the server that we've created it. So really important thing that we haven't talked about yet is that IPFS is actually running locally in your browser when you run web native. There is a JavaScript implementation called JS-IPFS where you are running a local node in your browser. And so when you first do this right, you're writing it locally. When you say await fs. Or when you say fs.publish, you're telling the server to come get the local change. And then,
Just let's maybe take a look at file to uint array. I think is defined here in the template. We may want to take a glance at that because I think that might be specific towards files like blobs, right? So we may want to create our own little helper function that's I don't know, text to uint array, and then get like a use the browser's text text encoder API. Actually, this is in the this might be a good opportunity to look at the README for web native on the refactored version. I think we have an example of how to do this.
In the README in GitHub or the README in
the README in GitHub? Yeah.
While you're looking this up, I wanted to ask: does IPFS have the concept of paths and all this stuff, or is it just IDs?
Yes, it is. No, it does not have the context of paths, and it's just IDs. So the calling IPFS is actually misnamed. People call it the interplanetary file system. You should think of it as like the interplanetary file store. Like think of it like an S3 bucket, like where you just throw stuff in. And so if you want things like paths, private files, public files, that kind of stuff, you have to layer on all of that yourself. And so WinFS provides all of that for you, of like all the things you would expect from a file system.
And through APIs that make it look like you're just typing commands in Unix.
Yeah, exactly.
Really nice. Yeah.
Yep. Cool. So we can now. I just grabbed this from the README on the right over here. There's an example of how to write a file, and I think this will work. I think we just need to change the type here. TypeScript man, Brian,
String.
what type is this going to be? String? All right, cool.
Lowercase, I think.
Oh, yeah.
Yeah.
Switch
and then, yeah. You beat me to it.
Sweet. All right, so if I go back over, we now have this upload avatar to WinFS. I no longer need that import.
Rename it.
Oh, yes. Good call. Upload vcard to WNFS. And we'll go back over to our auth svelte, and we will not need the file system store. We'll need to import this from utils, is what it's guessing. Is that right?
Nope.
It is.
It's going to be $lib vcard, I think is what we called it.
Does the $sign go inside the?
Yeah, totally. Yeah, and after the slash, you want vcard, I think is what we named the file.
Oh, right. Yeah, you're right. Cards.
But maybe not in utils. I don't know.
It was in there. Let's see.
Oh, was it? Okay.
I put it right next to the other ones over there. Oh, it's not in utils. Yeah, it's in just $lib vcards. All right, here we go. Okay, cool. We got it. Now our save to IPFS should call this function, upload vcard to WinFS, and I think it's just going to be card.toString. Card to string.
And I think our upload to vcard to WinFS is async, so maybe throwing a wait on that as well.
I think you're right.
And then you'll need an async on 18.
Async here.
Yeah.
All right, there we go. Let's see if it works. That was a lot of coding without clicking. Let's see if. Let's see. All right, so I promised a spinner when I clicked save card to IPFS. Let's see if we win. Oh, there it is, right there.
Oh, amazing!
Wow, your V card.
I was betting against you on that one, Jeff.
I was betting against me too. but notice that it's still spinning. So I kind of that's half a mistake. Brian was saying half a mistake earlier.
So we're up to 3 now, right? Okay.
2.5.
Okay. So just to point out a little bit of the debugging messages down here, the first, well, the one that says adding SID to ledger, that's or adding to the SID ledger. Locally, WinFS keeps track of SIDs that are like the sort of root SID for the entire file system. And so since we've added a file, we're updating what the SID is for the file system. So that first message is when we're doing it locally. Updating the DNS link is when we're updating how you would access it, or we're updating it with the server. And we do some things so that you're able to access the file over HTTP. And then the last one, there was one more down there, DNS link updated. So once DNS link is updated, you know that your file is like out there on IPFS and not just in your browser.
All right, remind me how I get to it. Jess Martin 2.
Files, Jess Martin 2, or yeah, Jess Martin 2. Let me see if I can remember it too. No. Sorry, start with Jess Martin 2. You were right. .files, .fission, .name, I think. Let's see if
boom. Well done. All right. Private. No, that wasn't the one.
Oh, okay. Yeah. So private files we're not going to be able to really directly view here, right? Because they're encrypted.
Of course. Yep.
Yeah.
So we made it private. We should have made it public.
That's so cool, though. That's a demo, isn't it?
Yeah.
You're gonna fix it now.
It is actually on IPFS. It is. You cannot see it. It's in the private file store, which is appropriate.
That's actually a better demo than seeing it, isn't it?
Yeah.
Sure.
We all know how to write public data to the IPFS.
It's encrypted. It worked.
Yeah, exactly. Cool.
Amazing. So,
okay. So yeah, we got through. Man, we went through a lot. That was how UCANs work, device linking, and public key cryptography, all the way through saving files onto IPFS using Web Native. So yeah.
So if we had another hour, what would we do?
Hey, check it out. vCards.
Nice.
I had to save it as a public because I thought it would be a cool demo there. Here we go. Userland.vcf. Add that card. There it is. Acme Inc.
Super cool.
Nice.
So if we had another hour, what I would do is build this out to where you could actually have an address book of being able to read from a directory of VCF files on IPFS, list them out, switch between them, and then edit and create new contacts within IPFS. So like basically a fully functioning address book. And I think you can kind of see from where we're going that it wouldn't actually be that much more code.
No.
Reading from IPFS is not that different from writing. In fact, we saw an example of that when we were looking at the avatars. It's just an LS, and then you get back a list of files. And so it would just be building the HTML and CSS to iterate over those files and show them and then those very simple saves. So,
yeah, great. So I'm hoping I can convince you to do another hour at some point soon.
I'd love to.
Maybe I could even try to type, and then you can yell at me when I type the wrong thing.
Ooh, that would be fun.
I can pretend I'm still a programmer. Yeah, I mean, I think it would be really great if we could do this again and finish that part, and then I can ask more questions about how stuff works, because I think that would be really interesting, especially on the WinFS thing.
Yeah, sounds good.
Sounds
Great.
awesome.
Well, thank you so much. This is this is more fun than I thought it would be, but as educational as I had hoped as well. So really, really great to work with you, and thanks for all the prep too. Definitely nicer to have you pasting things in than typing everything. Although, Jess, you're a very quick typist. I just want to say,
Thanks.
Impressive.
Thanks.
It's the Vim thing. If you don't use Vim, then you stand no chance of competing with Jess. So So do you want to just give the URL again for anything? But I know that like the template might be a good thing to put up again at the end.
Yeah, so the thing that you should definitely check out if you want to use this, I'll go ahead and hit present again really fast, share screen, share, and boom, boom. Yeah, so the thing you're going to want to check out that will allow you to quickly build apps like this would be the Web Native app template. Like I mentioned, it uses Web Native under the cover, but this is where you should go to get started. And you can quickly tear this down, turn it into your own app. If you want to see what we did today, and if you'd like to jump off from there, right after this call, I'll do a commit and check in against WN Contact's example. And so WN Contact's example is in the Web Native examples repo. If you go down here and scroll to the list of repositories, you'll see it. And you'll see all the code that we wrote today. Not that it was particularly impressive, but you could pick up the Contact app and see if you could implement writing multiple VCFs to a single directory, reading them, and updating the Svelte files. So kind of where to start. If you have questions about any of this stuff, feel free to jump into the Fission Discord. We're all hanging out in there and happy to answer questions. And also, I think just about every single thing that we do is available on the internet as open source. So if you're thinking that this would be a cool thing to work with, feel free to go to the Fission Codes GitHub org or the Web Native Examples GitHub org, and pull requests welcome. So
great, thank you. And the Fission Discord is available as a link on fission.codes, upper right.
Yeah. Yep. You got it right down here. Discord chat. Join our Discord.
All right. Well, thank you. And now I know that I can say see you next time. I'm looking forward to it.
Awesome.
That's great.